2023 paper 2. Question number 1, it says we've got a triangle PQR and we want to find the equation of the altitude from P. So the first thing you do is you write down all the vertices, all the coordinates on your triangle. Make sure you copy them down properly before you start. An altitude coming from P. So an altitude meets the opposite side at 90 degrees. So you don't have enough information on that altitude. That straight line, you only know one thing about it there. You only know one coordinate, but you do know it's meeting that one at 90 degrees. So what you do is you ignore where it's coming from and you work out the gradient of QR. And just do that with your y2 minus y1 divided by x2 minus x1. So when we sub in our coordinates, we end up with a gradient of QR and it's equal to 1/3. So we've got the gradient of that line there, but I want the gradient of the altitude. But we know that lines that are perpendicular, if we multiply their gradients together, that's called the product, it is -1. And in fact, we can just flip and change the sign if we write that down to give us the gradient of the altitude. So gradient of the altitude. So gradient of the altitude, flip and change the sign, becomes 3. So now we want the equation of the altitude. So to get the equation of any straight line, we need two things. We need the gradient and we need a point in the line. And once we've got them, we substitute into y minus b is equal to m times x minus a. So remember that is a and that is b, and we've got the gradient there m. So y minus b becomes y minus 1 is y plus 1. That's equal to the gradient, which is 3 bracket x minus a, so it's x minus 5. We'll multiply the bracket out, so y plus 1 is equal to 3x's minus 15. And to finish it off, I do not want that plus 1 there, so I want to undo it. So I'll take 1 away from both sides, so y is equal to 3x's minus 15, take away another 1 is minus 16. Double underline your answer. For part B, it says calculate the angle that the side PR makes with the positive direction of the x-axis. As soon as you see positive direction of the x-axis, you should be writing down gradient is equal to tan theta. So we want to find the angle. So if I want to find the angle, I've got to know the gradient. So I'm going to work out the gradient of PR. So I'll do m PR. And we do it with our y2 minus y1 divided by x2 minus x1. So we've got the point P, which is 5 minus 1. We've got the point R, which is 13.3. So y2 minus y1 is 3 minus 1, so it's 3 plus 1, divided by 13 minus 5. When I work that out, I get 4 over 8. We've always got to simplify, so 4 over 8 is the same as a half. So that then tells me that the gradient is a half, so therefore I can use that to work out tan theta. So that means that tan theta is equal to the gradient, so tan theta is equal to a half. It's a paper 2, so we can use a calculator. We want to work out the acute angle, and the acute angle is tan to the minus 1 of a half. So when you put that into your calculator, you get 26.6 degrees. Now we've got to think about what quadrant, but tan would be positive in quadrant 1 and quadrant 3. Quadrant 3 would be an angle that is bigger than 180. So our answer there for theta, for the angle that it makes, is 26.6 degrees. So it is the quadrant 1 answer. Question 2. For this question, it says find the equation of the tangent to the point with the equation y is equal to 2x to the power of 5 minus 3x at a point where x is equal to 1. So when you're doing this, remember you've got your headings point, you've got gradient, and you've got the equation of your straight line. So point, gradient, and equation. So write down your headings, underline them. Now, we only know one thing about the point. We know that its x-coordinate is 1. We don't know the y-coordinate. So we go to the y equation, the initial equation, and we sub in to find out what the y coordinate is. So we've got 2x to the power of 5 minus 3 times x. That becomes 2 times 1 to the power of 5 minus 3 times 1. That is going to be the same as 2 take away 3, which is equal to negative 1. So we've now got that y coordinate. We now want the gradient. So we go to the equation, and the gradient we know is equal to dy by dx. So we've got to take the derivative. So the gradient then is going to be, take the derivative of that, 5 times 2 is 10x to the power of 4 minus 3. Now we want to find the value for the gradient, but we know x is equal to 1, so we sub x equal to 1 into there. So we'll get 10 times 1 to the power of 4, and that's minus 3. So that becomes 10 times 1 is 10, minus 3 is 7. So now we've got enough information to get the equation. We've got the gradient is equal to 7, and we've got the point in the line, which is 1, negative 1. And we do y minus b is equal to m bracket x minus a. So y minus b becomes y minus minus 1, so it's y plus 1. That's equal to 7 bracket x minus 1. Multiply out your bracket, so y plus 1 is equal to 7x's minus 7. Don't want that plus 1 to be there, so to undo it, we take 1 away from both sides. So y is equal to 7x's minus 8. Double underline your answer. Question 3, we want to find the integral of 7 cos bracket 4x plus pi over 3. And we're doing the x's. So this pi over 3 is just a number, you just ignore it. So I've copied down there your table of integrals. That's from your info sheet. So that's at the front of your booklet. So we want the integral of cos. So there's the integral of cos there. So first thing we do is we just write that 7 down. Okay, it's sitting in there, just leave it there. Integral of cos becomes sine. So we'll put in sine. The angle stays the same, so in the bracket you've got 4x's plus pi over 3. Now we'll go back to this. Whatever is with the x, you divide by it. So the number with the x here is a 4, so we're going to divide the whole thing by 4. And of course, when you take an integral, you must put in a plus c. The diagram shows the graph of a cubic y is equal to fx, and it's got stationary points at the point 2, 0, and 0, negative 2. So there's a wee stationary point there, and there's a wee stationary point there. It then says on your diagram in your answer book, so you've got a booklet with axes drawn on it, you've got to sketch the graph of y is equal to 2f of negative x. So first of all, this negative x in here, that tells you that you're reflecting in the y-axis. So remember that when you've got anything inside that bracket with x, you're changing the x's. So what you're really doing is you're doing the opposite. So that is minus 1 times x. So what you're doing is you're dividing by minus 1. So in other words, you're changing the sign of all the x coordinates. When you've got a 2 in front of that, you're multiplying the whole thing by 2. So basically you're changing the y coordinates by multiplying them all by 2. The effect of that is that it stretches your graph up and down the way. So anything that's outside of this bracket, it changes it up and down the way. Anything inside that bracket, it goes across the way. So we've got to take this graph and we've got to flip it so that this bit here ends up over there. And then we've got to take this part here and flip it over to there. Now what we'll do is we'll do the coordinates first. So we'll start with our coordinates that we're given. Make sure you take every single one of them. So that one there is negative 1, 0. Then we come to this one, which is 0, negative 2. And the only other important point on there is 2, 0. So what we'll do is we'll do the reflection first. So what we're doing is we're dividing the x numbers by negative 1. So in other words, we're changing the sign of all the x's. So that becomes 1, 0, y stays the same. That becomes 0, because you can't have a negative 0. That stays the same. That 2 becomes negative 2, and the y stays the same. Now, I'm going to draw that, but it's a reflection of this thing here. So I'm drawing the intermediate stage of this. So I've drawn this out, so you can see that this part here, that stationary point is flipped over there. There it's there, at that point there. This bit's on the mirror. it stays on there. That point stayed there at -2. And this point here that was at -1 has flipped over there and it's going to 1. So that's us, we've completed that reflection there. So the next thing now I have to do is I need to multiply the y coordinates by 2. That's this transformation. So I'll draw that down here. And what this does is it stretches the graph up and down the way. So the point 1, 0, x stays the same. Nothing times 2 stays at nothing. We've got 0, -2, x stays the same, and that goes to -4. X stays the same, it stays at -2, and nothing times 2 is still nothing. So this graph then, when we stretch it, it becomes that 1, 0 stays at 1, 0. I'll draw it in a different colour, so that stays there. Then we've got the point 0, -4. 0, -4 will go down there somewhere. I'll make that line a wee bit bigger. And we'll make that -4. And the last point we've got there is -2, 0. That's on the mirror and it stays on the mirror. So there is -4 down there. So the graph is like that. It's been stretched away down to there and it goes back up through that point there. And that's your graph of y is equal to 2f of -x. Question 5. A function f is defined by fx is equal to 3 minus 2x all to the power of 4. Calculate the rate of change of f when x is equal to 4. So rate of change means a derivative. So rate of change is dy by dx or f dash x. We've got fx here, so rate of change is f dash x. Now, this is one of your bracket ones, so the rules for multiplying out, or to take the derivative of that bracket, is to multiply by the power, keep the bracket in there, take 1 away from the power, so that would become 3, but we've got to multiply by the derivative of the bracket, so derivative of 3 disappears, derivative of -2x becomes -2. So we're going to gather that all together, so we've got -2 times 8, times 4, sorry, gives me -8. And we'll fill in the bracket, and the bracket becomes 3 minus 2x, and it's all to the power of 3. So that's basically your derivative. The rate of change now is that with a value substituted in. So rate of change is going to be equal to -8, bracket 3, minus 2 lots of, and we want it when x is 4, 2 lots of 4, all to the power of 3. So we'll tidy that up. So we've got -8 in the bracket. We've got 3 minus 8, which is -5 to the power of 3. So we need to do the power part first. So -5 times -5 times -5 is -125. So we've got -8 multiplied by -125. 2 negatives make a positive, and 8 lots of 125 is 1,000. So the rate of change of that function, where x is equal to 4, is 1,000. So we take your derivative and substitute in your x value. Question 6. A function f is defined by the function fx as 2 over x plus 3. X has got to be greater than 0. That's for your domain. You can't divide by a 0, that's why it's in there. It says find the inverse function f inverse x. So when you get an inverse function, all the x's changes to y and the y's change to x, they swap round. So what we do is we say let y equal to 2 over x plus 3. So what I want to do is I want to change the subject of this so I can find out what x is. So the first thing I want to do is I want to write it round the other way. That's what you're used to doing, so I'll just do that. And that's equal to y. Now there is a problem, x is at the bottom, but we'll worry about that in a wee minute. We've got to get rid of this plus 3, so we've got 2 over x is going to be equal to, take 3 off both sides, so it's y minus 3. Now, I've got to get a way of getting that x term from the denominator to the numerator, and what we do is we multiply both sides by it. So we're multiplying both sides by x. So when I multiply this side by x, I end up with 2. And when I multiply this side by x, I've got x bracket y minus 3. Now it looks as though we've gone a step backwards, but we haven't, because we've got x now in the numerator. Read it round the other way. X bracket y minus 3 is equal to 2. I don't want that bracket that's multiplied by x to be there, so I divide both sides by it. So I get 2 divided by y minus 3. Now basically your answer is sitting there, but we were asked to find the inverse function f inverse of x. So we've got to write it in terms of x, so it becomes 2 over x minus 3. We want to solve the equation sin x plus 2 is equal to 3 cos 2x. There's the important bit there. We've got a double angle formula. So when we're solving any of these things, we want to make them equal to 0. So I'm going to write this round the other way. So I've got 3 cos 2x, and it's in degrees. And that would be equal to sin x degrees plus 2. I want to make it all equal to 0, so I'm going to take sin x away from both sides, and I'm going to take 2 away from both sides. And when I do that, I get 3 cos 2x minus sin x minus 2 is equal to 0. Now, what you've got to do is, you've got to do your replacement for your cos 2x. There's 3 replacements for cos 2x. There's one where you have got 2 cos squared. You've got cos squared minus sin squared. You ignore that one. You never ever use that one. You've got 2 cos squared x minus 1. And you've got 1 minus 2 sin squared x. So what you do is you look at this term here, and this guides you into the one that you're going to use. So you're going to use the replacement that is in terms of sin. So we write down 3, don't forget the wee 3, and we're going to replace this from our information sheet with the sin one. We're using the sin one because that term is sin. So we've got 1 minus 2 sin squared x, and then we've got this minus sin x, and then we've got a minus 2, and that's equal to 0. If you've got a bracket, you always multiply your bracket. So 3 times 1 is 3. 3 times minus 2 sin squared x is minus 6 sin squared x. We've got a minus sin x, and we've got a minus 2, and that's equal to 0. So we've got 2 number terms there. We want to gather them together, nothing else that can be gathered together. So when I do that, I get minus 6 sin squared x minus sin x, and we've got 3 take away 2 gives me plus 1, and that's equal to 0. Now when you've got squared terms, normal terms and numbers, the key to solving that is to factorise, and this is no different. Now I do not like that squared term that's got a negative sign, so I'm going to multiply this whole equation by negative 1. It's just like taking them all over to the other side, but it makes it easier. So that will become 6 sin squared x. That will become plus sin x, and that will become minus 1, and that's equal to 0. So we want to factorise this. I don't like all these sin squares and things around. So what I'm going to say is I'm just going to say let sin x equal s, and it simplifies all of this. So what I've got then is I've got 6s squared plus 1s minus 1 is equal to 0. So we want to factorise that. So I'm looking for factors that multiply to give me 6 times minus 1 is negative 6. The negative 6 tells me that the factors will have different signs. So I'll just write down the factors just now. So it's 1 and 6, and it's 2 and 3. So I'm looking for a pair of factors there that gives me 1, a plus 1, and I know that they've got different signs. So the 2 factors then that I'm looking for are, I want plus 3 and the minus 2. So we're going to factorise that now. So I've written down the factors. If possible, if there's one that's positive and negative, write the negative one first. So we've got 6s squared minus 2s. Highest common factor is 2s. That leaves me a bracket of 3s minus 1. There's my cheat bracket, 3s minus 1. I'll write it in there. What do I do to change 3s into 3s? I multiply it by plus 1. So now I've got the 2 brackets sitting there. I've got 2s plus 1, and I've got 3s minus 1. And all of that's equal to 0. So at this stage, we'll change it back. Okay, so I've got 2 sine x's plus 1 bracket 3 sine x's minus 1. And all of that is equal to 0. So if we're multiplying two things together and they're both 0, the answer comes out to be 0, then we make 2 sine x plus 1 equal to 0 and 3 sine x minus 1 equal to 0. We'll rearrange that, and when we rearrange that one, we're going to get sine x is equal to minus a half. So we'll take one away from both sides, divide by 2. And on this side here, I'm going to have sine x, add 1 onto both sides, divide by 3, so sine x is 1/3. We've got our calculator, but you should know that if sine is a half, then the exact value is, for your acute angle, is going to be 30 degrees. That's when you don't know. So to get your acute angle, you're going to do sine to the minus 1 of 1/3. And when you do that, you get 19.5 degrees. Right, I'm going to go back to this one. So we know that sine is negative, and we've got a cast diagram. So we want to know where sine is negative. Well, sine is positive in quadrant 1 and quadrant 2. So it's got to be an answer in quadrant 3 and an answer in quadrant 4. To get into quadrant 3, we've got 180 plus the acute angle. That would give me 210 degrees. To get into quadrant 4, it's 360 minus the acute angle. So that will be 330 degrees. So that's that one done. Over here, we've got sine's positive. So sine's positive in quadrant 1 and quadrant 2. So we've got an answer in quad 1 on this side and an answer in quad 2. Answer in quad 1 is very easy. It's just your acute angle, so it's 19.5. Answer in quadrant 2 is 180 minus 19.5. And when I work that out, it gives me an angle of 160.5 degrees. Now, that's your answers. There's 4 of them. Always end up by putting them in a bracket, listing them down. Usually you list them in smallest to largest, but it doesn't matter, you'll still get marks. So 19.5 degrees, 160.5 degrees, 210 degrees, and 330 degrees. And then double underline your answer. Question 8, and this is for 5 marks. It says a diagram shows part of the curve y is equal to x cubed minus 2x squared minus 4x plus 1, and the line with equation y is equal to x minus 5. The curve and the line intersect at the point where x is equal to negative 2 and x is equal to 1. So we want to find the shaded area. The shaded area, in fact, is this whole bit in here. It's not come out very well in this diagram, so that's it all in there. So what we do is, for the shaded area, there is only one part of it, so it's not 2 parts of this. So the shaded area is equal to the integral, and the limits are going to be negative 2 and 1, so negative 2 and 1, and it's of the upper curve minus the lower curve. And to find out, don't forget your dx, we're doing the x's. To find out which one is the upper curve, which one is the lowest curve, imagine a man standing in there. Where's his head touching? Where is his feet touching? His head is touching that one. So it's the integral of, I'll put the one that's in just now, the upper curve, which is x cubed minus 2x squared minus 4x's plus 1, keep it in a bracket, and then take away the lower curve. His feet are resting on the straight line, which is x minus 5, and we're going to do the x's. The x must be written in there. Before you do anything, get this all tidied up. That negative sign will make that minus x, and that negative sign will make that plus 5, because that's effectively multiplying by negative 1. So I'm going to expand that bracket and tidy it up. Okay, I've substituted in 1 every time I saw an x, and I've substituted in -2, and remember we take them away. So you've got to be really careful doing this. So be careful if you're using a calculator, make sure you're careful at every stage. So this first bracket, that becomes a quarter. The second term becomes minus 2/3. The third term becomes minus 5 times 1 over 2 is minus 5 over 2. And 6 times 1 is 6. So that's the first bracket. Keep it in a bracket. Then we've got take away. So we're going to do this one. So we've got minus 2 to the power of 4. So minus 2 times minus 2 times minus 2 times minus 2. There's an even power. So that means that's going to turn out to be positive. So that is going to be 2 to the power of 4. 2 2s are 4, 4 2s are 8, 2 8s are 16. 16 divided by 4 gives me 4. Minus 2 to the power of 3 gives me -8. Negative 8 times -2 gives me plus 16, and that's in thirds over 3. Then I've got minus 2 squared, which is going to be 4. 4 divided by 2 is 2. 2 times minus 5 is minus 10. And then I've got 6 times -2, which is -12. Okay, so now we want to tidy up those values. When I do that, so just put them into your calculator and check them. I get 37 over 12 minus 38 over 3. So remember, two negatives make a positive. So that gives me 63 over 4. When you work that out, just use your calculator, and that turns out to be 15 3/4. Okay, so stop the recording and then put them all in, check you get the correct answer, and make sure that you don't make any mistakes putting them into your calculator, because that's a tricky bit. Question 9. Express 7 cos x minus 3 sin x in the form. So we've got a wave function, and then hence or otherwise find the maximum value of that thing and where it occurs. Okay, so we'll set up our wave function. So I've equated both of them, I've expanded the formula. So your sine A plus B comes from your information sheet, and it's sine cos plus cos sine. Then put the angles in order, x and a, repeat x and a. Now don't forget the k goes in front of this term and in front of that term. So we've got two equal statements here. So what we want to do is we want to see what things are the same. So I'm going to highlight cos x, and I'm going to go over the other side and see if I can find cos x, and there it's there. So if these two statements are the same, it means the things that are with cos x on both sides have also got to be the same. So remember here, you've got two bits round about this, and don't forget the sign. Sometimes that can be negative and it's got to go with it. So with cos x in this sign, we've got k sine A. So that must be the same as 7. We do the same with the next term, which is our sine x. There it's there. We find it in this side. There it's there. So we compare both of them. They've got to be the same. So we've got minus 3 on that side, and on this side we've got k cos A. So k cos A is equal to, and don't forget your minus signs, is equal to minus 3. So two things we want to find. We want to find out what k is. We want to find out what this angle A or alpha is. So to find out what k is, we square both of them. And because we're squaring, we're getting k squared. So k squared is 7 squared plus minus 3 all squared, which is 49 plus another 9. And that gives us 58. I don't want k squared, I want k, so k is equal to the square root of 58. Sometimes that can be simplified. Okay, sometimes you can put that into your calculator even and simplify it in a simpler sort, but that one we can't simplify. So the next thing we want to do is we want to find out what the angle is. So to get the angle, we're combining those things that we know. This is the most important thing here on that whole page of working. That's the two equations that are going to give me the answers to everything. So we are going to use those two equations and combine them in some way so that I can work out an angle. And you just learn this. You're going to combine both of them to get tan. So you don't need to write this out all the time, okay, if you know how to do it without doing it the long way. So I'm writing down those two equations, one under the other, and there's a k sine A is equal to 7, k cos A is equal to -3. So what happens is those k's cancel, and sine over cos is tan, so I end up with tan A is equal to, always bring a negative sign up, is -7/3. Now you can go straight on to that stage, okay, if you want. Right, so what we've got to do is, we've now got to find A, we've got a trig equation, so we're going to do acute angle. So we'll do tan inverse, drop the negative sign of 7 divided by 3. And when I do that, I get an angle of 66.8 degrees. Now, we normally work out our quadrants, but we've got to take into account sine, cos, and tan. So there's the cast diagram. So what you do is you go through each one of them in turn. So I'll start with tan. Tan is negative. So tan is negative in quadrant 2 and quadrant 4 because it's positive in those two. Then I look up there and I say sine. Well, sine is positive. Sine is positive in quadrant 1 and in quadrant 2. Then I look at cos. I want cos to be negative. Cos is positive in those two, so it must be negative in there and in there. So when you do that to locate where your angle is, you should have one box with 3 ticks. That's the quadrant your angle is in. And you should also have one tick in each of the other boxes, just as a wee check. So I know that this angle A is in quadrant 2. So to get into quadrant 2 is 180 minus the acute angle. So I've got 180 minus 66.8 degrees. So this angle A is 113.2 degrees. So when I go back and I put it all together, I've got 7 cos x minus 3 sine x, that's back to the question, and that's all equal to k, and k was √58, and the option was sine, so it was sine x plus a, so it's x plus 113.2 degrees, and that's the wave function completed, part 1. For part 2, we'll go back up and see what the question is. It says, cancel or otherwise, find the maximum value of that thing there. It's only for 1 mark. And find the value of x where it occurs for 2 marks. So we're going to have a wee look at that. So part B, cancel or otherwise, find the maximum value of 14 cos x minus 6 sine x. How does that relate to that one? 14 is 2 lots of 7. 6 is 2 lots of 3. So basically what we've got is we've got 2 lots of that. So the maximum value is not going to be √58, it's going to be 2 times √58. And that's your maximum value. Now for 2 marks, we want to find out where this occurs. So what we've got to do is we've got to think about what this thing looks like. So I'm going to draw down that sine graph. So we've got a graph that looks like that, and remember that's 180 in there, and that part in here would be 270. So that's our sine graph. So that's 2 √58 sine x plus 113.2. So we want to know where the maximum value occurs. If it didn't have anything in the bracket, but it was just x, the maximum value is that bit there, and it would occur at 90 degrees. But in that bracket, we've got x plus 113.2. So remember, in the bracket, it changes the x coordinate. X's are always wrong, that's why it's the wrong symbol for them. So instead of adding 113.2 onto the x number, we're going to subtract. So we're going to subtract 113.2 degrees away from 90. So that's getting moved that way. It's going away back there. So when I take 113.2 degrees away from 90, that means that that graph has shifted to minus 23.2 degrees. Now I can't have a negative 22 or 23.2 degrees, so it's out of range. It's way over here. It's flipped over there. So what you do is to bring it back into 0 and 360, you add 360 onto that. And when you add 360 onto that, you get the x value is equal to 336.8 degrees. And in fact, the sine graph keeps going. Okay, it keeps going on and on and on. So there's been another maximum over here at that point, and it's really that one that's been moved, and it's that one that we're finding. But just learn to do that. It goes out the range, it's negative. All you have to do is add a period onto it to bring it back, which is 360. Question 10, it says determine the range of values of x for which fx equal to all of that is strictly decreasing. So when is a function decreasing? It's decreasing when f dash x is less than 0. So that's your condition, we write that down first. So it's when f dash x is less than 0. So what we're going to do is we're going to work out f dash x. So f dash x is equal to, it's going to be 3 times 2 is 6x squared plus 18x's minus 24. So we really want to solve 6x squared plus 18x's minus 24 is less than 0. So keyword is we're going to factorise that. We've got to sketch the parabola to solve that. You can't solve it any other way, it's got to be from a sketch. So another keyword there is to sketch it. So what we want to do is we want to factorise this. I can see a common factor of 6. I'm going to take that common factor out and then I'm going to factorise the brackets. I've taken out the common factor of 6. I've divided both sides by 6. It just leaves me the quadratic, which is much simpler. I've factorised the quadratic. 2 numbers that multiply to give us -4. Combination gives us 3. We've got them there in the bracket. So now I want to sketch this. So I'm going to let that be x minus 1 times x plus 4. I'm going to make it equal to 0 just to sketch. So this is for the sketch. So that means that x minus 1 is equal to 0. Or x plus 4 equals 0. So that gives me roots at x equal to 1, and the other root is x equal to -4. So now we've got to sketch that parabola. So last thing I have to do, it's all sketched, there's the roots there, at -4 and +1. I want the bit where it's less than 0. So less than 0, that's your y really value there. So the y value's got to be less than 0. So all the parts that the y coordinates are negative are all of those bits there. It's one continuous section. And to describe that continuous section is x is in between -4 and 1. And you write it like that. Question 11. Circle C1 has equation, circle C2 has equation. One is in the format with the brackets, another is the extended, the multiplied out formula. Calculate the distance between the centres C1 and C2. So the first thing we've got to do is we've got to write down the coordinates of C1 and C2. So C1, to get the coordinates of that, you go into the bracket and you change the sign for the x, and you go into the bracket, change the sign for the y. So centre C1 is 4, -2. Centre C2, you go to the x value, you half it and change the sign so it becomes -1. You go to the y coefficient is -6, half it and change the sign gives us 3. So now I want to find the distance between those 2 points. You can use the distance formula if you want. I draw a triangle. Okay, so I am just going to draw a wee triangle and I'm going to put C1 and C2. I'll put that as -1, 3. It doesn't matter what order you put them in. And that's 4, -2. So we're looking at the x numbers and we just want to know how many boxes between the x numbers. So it's at -1 and the x number went up to 4. So from -1 to 0 is 1 box, 0 to 4 is another 4. So there's 5 boxes between them and the x-axis. The y-axis, we're at 3 and -2. So -2 to 0 is 2 boxes, 0 to 3 is another 3 boxes, is 5. So the distance between the centres, we'll call it x. X squared is going to be equal to 5 squared plus 5 squared, which is 25 plus 25, which is 50. I don't want the square, so I want to take the square root. So x is equal to the square root of 50. Now that can be simplified to 50 is 25 times 2. Square root of 25 is 5, so that could be written down as 5 root 2. But also, as a decimal, is 7.07. Okay, so we could be using either of them. So that's the distance between the two centres. Next thing I've got to do is I've got to show that if C1 and C2 that they intersect at two distinct points. So what we've got to do is we've got to draw the diagram for that. Okay, I've drawn down the two circles C1 and C2. So there we have them. If they were touching, then the distance between the two centres is the radius 1 plus the radius 2. If they do not touch, then the distance between the two centres is much bigger than the radius 1 and the radius 2 added together. But they want me to show that, and I'll go back and check, that they intersect at two distinct points. So what that means is I'm going to move that circle, and there it's touching at one point, and now they're intersecting at two different points. That's them there. So if that's the case, then if I take the distance between the two centres, it's going to be smaller than the radius 1 plus the radius 2. So I'm going to work out radius 1 plus radius 2, and I'm going to compare it to the distance between the two centres. So we'll look at the equations of the two circles. So I'm going to go back up to the start, and the radius of that one there, it's in the format where we've got x minus a all squared plus y minus b all squared is equal to r squared. So the radius of that one, so we'll call it radius 1, is equal to the square root of 37. Okay. And this one here, to get the radius of that one, I've got to do the calculation. So it's going to be the square root of, and it's going to be g squared plus f squared minus c. So we're taking that from the centre. So remember, it is minus g is your centre. So it's going to be 1 squared plus, and that's going to change to minus 3 all squared. When you square them, it makes no difference because negative numbers disappear. And I want to take away this last number, but it's negative 7, so I want to add on 7. So when I do that, I get the square root of 1 plus 9 plus 7. So 1 plus 9 plus 7. So the radius of that one is the square root of 17. So I'm looking at the radius 1 is root 37, radius 2 root 17. I want to know the distance between them. So radius 1 plus radius 2 is root 37 plus root 17. I've changed them into decimals because I can compare them. So the distance between, or the distance with R1 and R2, so radius 1, there's radius 1, there's radius 2, added together is 10.2. But the distance between the two centres is smaller than that. So since R1 plus R2 is bigger than C1 to C2, the circles intersect at 2 points. Question 12 for 4 marks. It says a curve for which dy by dx is equal to 8x to the power of 3 plus 3 passes through the point negative 1, 3. Express y in terms of x. So they've given me the derivative. They want me to go back. So the opposite of doing the derivative is to take the integral. So y is going to be equal to the integral of 8x cubed plus 3. And don't forget dx, we're doing the x's. Rules for integration, add 1 onto the power, divide by your new power. So that gives me 8x to the power of 4 over 4 plus 3x's and plus c. We'll carry that y down there. Now I want to tidy this up a wee bit. So y is equal to 8 divided by 4 is 2. So that's 2x to the power of 4 plus 3x's plus c. So I need to find out what c is, but they will always give you information from a point. So that means that x is equal to -1 when y is equal to 3. So I'll sub those two values in and I can work out what c is, and that's it completed. So y, write it underneath it, y is 3, x is -1, so it's 2 times -1 to the power of 4, plus 3 times -1 plus c. And we'll work out that just now. So 3 is equal to -1 is negative, but it's a positive power, or an even power I should say. So that makes that positive. So that's going to be 1. So that's 2 minus 3 plus c. So 3 is equal to -1 plus c. You can write it around the other way to solve it. So c take away 1 is equal to 3. So c is equal to 4. So now you go back and you fill that in properly. So y is equal to 2x to the power of 4 plus 3x's, and we've got plus 4 at the end. Final answer, double underline. A patient is given a dose of medicine. The concentration of the medicine in the patient's blood is modelled by Ct is equal to 11e to the minus 0.0053 t, where t is the time in minutes and Ct is the concentration of the medicine at a time t. So part A, it says calculate the concentration of medicine 30 minutes after the dose was given. So they're telling me that t is equal to 30. So we go to our formula and we sub in t equal to 30. So we'll get c at time 30 is equal to 11 e to the minus 0.0053 times 30. Now stick all of that into the calculator. Be careful when you're doing it. So work out your power first, gives you minus 0.159 when you multiply the two of them out. So we're now doing 11 multiplied by e to that power. So you've got your e to the power of x on your calculator. Make sure the wee negative sign you're using the negative value that is above the numbers, it's not the takeaway. So that gives you 9.383. So 1 mark for that, not much because it's just a calculator one. So the second part, part B, it says the dose of medicine becomes ineffective if the concentration falls below 0.66 milligrams per litre. Calculate the time taken for this dose of medicine to become ineffective. So basically we want to find out when the dose is at 0.66 milligrams per litre, and then it'll become ineffective after that time. So we know that that's the concentration. So CT is 0.66, and that's equal to 11, and it's e to the minus 0.0053 and t, and it's this t we want to find. So what we're going to do is we'll write it round the other way and we'll tidy it up a wee bit. So 11 e to the minus 0.0053 t is equal to 0.66. I'm going to divide by 11. So e to the minus 0.0053 t is equal to 0.66 divided by 11. That gives me e to the minus 0.0053 t is going to be equal to 0.06. Now we're stuck, that's an exponential. The only way to change from an exponential is to a log in order to solve it. So we're changing to a log. The base is e, so it's log to the base e. The answer to the log is the power, so there's the power there. So it's minus 0.0053 t, and the bit I've not used is 0.06, so that goes in there. Now I'm going to change it to the proper notation. I know that the natural log is given by that symbol. Okay, and that's all equal to this thing here. I want to work out what t is, so that's staying, and I'm going to divide by that. So t will be equal to natural log of 0.06 divided by minus 0.0053. And when I divide all of that out, I get 530.83 and the time was in minutes. So the medicine will become ineffective after 530.83 minutes. A net of an open box is shown. The box is a cuboid with a height of 8 centimetres. The base is a rectangle measuring 3x centimetres by 2x. It gives you the base is there. Now that side would fold up and that side there would come round along here. This side would come along here and that would be the front. So basically that's the base. And when this box is folded, that will be the back. That bit will be the front. And these bits will be the sides. Okay. So just to get a wee clear picture of what's going on. It says express the area of the net in terms of x and h. Now they're all rectangles. The area of a rectangle is length times breadth. So we need to get some sizes here. So that one there, that's the base. So the area of that is going to be equal to length times breadth. 3 times 2 is 6, x squared. Now we want the back, but we know it's going up a height of h, it's the same as that, and that attaches onto there, so it's 3x. So in there, length times breadth is going to be 3xh. The front's going to be the same, so that's 3xh in there as well. Now the sides, that bit there, will fold along here. So that's got to be 2x, that's still h. So that part there is 2xh, and the other side is exactly the same, so it's 2xh. Now we want to tidy all of that up, so the area is equal to, we've got 6x squared, so I'll write that down. And then I've got lots of xh's, so I've got 2 of them plus 3 of them is 5. 5 plus another 2 is 7, plus another 3 is 10, so it's plus 10xh. So that's the area. So that's as we've expressed it in terms of h and of x. Now, I can see right away that the alien letter here is h. Don't want h's in this. Okay, so they're going to give us information so that I can get rid of that. So part 2, it says determine, given that A is 7,200 centimetres squared, show that the volume of the box is given by. So tells me that whole thing is 7,200. So I've got 6x squared plus 10xh, and that's equal to 7,200 centimetres squared. So we've got to rearrange this thing to find out what h is. So the first thing I'm going to do is I am going to take 6x squared away from both sides. So 10xh is equal to 7,200 minus 6x squared. I want to find out what h is, so I want to divide by 10 times x. So h is equal to 7,200 minus 6x squared, all divided by 10xh. So we can tidy this up a wee bit, we can split it. So if I've got 7,200, we could divide it by 10xh, and then minus 6x squared divided by that. But I think what we'll do is we'll just work out the volume first, okay, rather than simplify first. So we want to find the volume of that box. The volume of that box is length times breadth times height. So we'll fill in the dimensions. The length was 3x, the breadth was 2x, and height was h. So it's 3x times 2x times h. So the volume of the whole box is equal to 6x squared times h. Now there's the alien letter. I know what it is, so I'm going to substitute that into the volume, and hopefully it'll turn out to be the same as that. So I'm substituting this h value in here. Okay, so when I do that, I get 6x squared times 7 2, 0, 0 minus 6x squared, all divided by 10x each. There's no h in there, okay, and there's no h in there, I copied it down. Right, so we've got to multiply all of this thing out, okay, so I'm doing 6 times 7200, x squared divided by 10x, and when I divide all of that out, I get 4, 3, 2, 0 times x. I'm now going to do our 6x squared multiplied by 6x squared divided by 10, and when I do that I get minus 18x cubed over 5, and that's hopefully the same as what we were asked to prove it equal to, and that's it. Next part, part B. Determine the value of x which maximises the volume of the box. So we're going to say max value, and it will be when the derivative is equal to 0. So write that down, underline it. So now we want to take the derivative of that term. So v dash x multiply by the power, take one away from the power, but it's just an x there, so that's just going to become 4,320. And then we've got minus 3 times 18 over 5. So 3 times 18 is 54, so it's 54 over 5. And it's going to be x to the power of 2. That whole thing's got to be equal to 0, and now we solve. So 4, 3, 2, 0 minus 54 over 5 times x squared is equal to 0. So I'm going to add this term onto both sides. So 4320 is equal to 54 over 5 x squared. Read it round the other way. So 54 over 5x squared is equal to 4320. So to get x squared, I don't want to divide by 5, so times by 5, but I've got to divide by 54. So it's 4320 times by 5 divided by 54. Okay, and when I do that, I get an answer of 400, and we want to take the square root of that, so x is equal to, is plus or minus the square root of 400. Remember, when you take a square root you get a plus value and a minus value. Now it's volumes of boxes and lengths and breadths, and that's what x is, so you can't have a negative length, so therefore x is equal to, we'll write both down, it's going to be 20, or x equals negative 20, not valid, it's a length. Always write that in just in case. Sometimes you're given a mark for that, for discarding that answer. So that's a not valid one. So x is equal to 20. So we're getting the maximum volume when x is 20. Now you've got to do your nature table. So draw it down. You've no calculations to do. So we've got x, we're going towards 20. We're going away from 20. We've got here v dash x, and you can write in shape, etc. So we know that we were looking for a maximum, so I know it's supposed to be like that. That was 0, that is going to be positive, that's going to be negative. So I'll get a maximum where x is equal to 20. You can stick a wee number in there, 19 and 21. Okay, and that's it completed. Okay, last question. So it says the line x plus 3y equal to 17 is a tangent to the circle at that point, and it says find the centre of the circle, it's on the y-axis, and find the coordinates. Okay, so there's the centre of the circle. If it lies on the y-axis, the clue from that is that it's going to have coordinates 0 something. X number is 0. So what do we know? I know that if I take that radius there, it meets at that point there, and it meets at 90 degrees. I've got to find basically this coordinate so that I can get the centre. So the only thing I can do is I can think about the gradient of the tangent. So gradient of that tangent, I'm going to rearrange that. So I've got 3y would be equal to negative x plus 17. I don't want 3y, I'm going to divide by 3, so the gradient of that one is going to be minus a third. So that means that the gradient of the radius has got to be, because m1 times m2, they're perpendicular, is negative 1. So the gradient of that radius has got to be 3. So that means I know that the gradient is 3 and I know the point in the line. So I could work out the equation. So we'll do equation. And the equation is going to be m is equal to 3. The point on the radius is 2, 5. It's a point in common with the radius and the tangent. So y minus b is y minus 5 is equal to m times x minus a. Tidy that up. So y is equal to, that would be 3x's minus 6. And I want to add on 5. So it's 3x's minus 1. So how does that help me then get this coordinate? Well, I know the x number is 0. So if I know the x number is 0, I can sub in there to work out the y coordinate. So we're going to sub x equal to 0. Why am I subbing x equal to 0 into that? Because I know that that was on the y-axis. So any point on the y-axis, x is equal to 0. So that means that y is equal to 3 times 0 minus 1. So y is equal to negative 1. So that makes the centre of that circle the point 0, negative 1.